Hi, I'm Mark, and this video is intended for teachers of AP Physics 2 or AP Physics C. This is a lab about internal resistance. It was first showed to me by Gay Stewart, who wrote physics for the AP 1 course. This is an old D-cell battery. After all the batteries and bulbs experiments were done one year, I asked students to test the batteries and tell me which ones had the lowest voltage. Then I put a mark on them and I set them aside for this lab. So I have little bags with one of these old batteries in it and the battery holder, like you see here, a few clip leads and 5 resistors. There's no magic to the choice of the resistors. I just had a big box of various resistors and I picked 5 that seemed like they would work for this lab, and they turned out to work. You could do better by having maybe a wider range or more even divisions between the values of the resistance. So I have a 10 ohm, a 1000 ohm, a 330 ohm, a 560 ohm, and a 100 ohm. Little tip, speed things up when doing the lab. I just had a student aide write out these cards for each one of the little bags with the lab. It tells the color code and the resistance value, so the kids don't have to look up the resistance value if you don't want them to. Speeds things up a little bit. Here's the circuit you're going to build. It's a really simple circuit. One resistor, the battery, and then you monitor current and voltage. I'll show you what that looks like in the next part. I'll show you the setup I would recommend for data collection. So I've got the battery here and then one of the resistors. It's a tangle, I know, sorry about that, but I have a differential voltage sensor. It's connected across this resistor and it's connected to a LabQuest 2. It'll monitor potential difference across the resistor and it'll work well. And then here I've got an inexpensive multimeter. It's in series with the resistor and it'll collect current. So let me go ahead and connect the circuit and see if we get a data point. I won't bore you with collecting all the data, but I will post some sample data. So now you see we've got about 840 thousandths of a volt and about 83 milliamperes. Just repeat that process 4 more times with the other 4 resistors. You can collect current data using a high-tech approach. Vernier sells a current sensor. I wouldn't recommend using that for this lab. You want to get a pretty low resistance resistor for one of your values, like I have a 10 ohm resistor in there. This sensor has a maximum current that it allows of 600 milliamps. If you exceed that 600 milliamps, there's a resistor inside that will fry and the sensor won't be worth using anymore. I don't think it'll register anything actually. This is a high current sensor. This would be able to handle up to 10 amps, and it has a fuse that's replaceable that if students exceed the 10 amps by shorting out the circuit, which won't happen with a dead battery but could happen with a live battery, then you can fix this by replacing the fuse. But this is not sensitive enough for this lab. I would recommend using an inexpensive multimeter, or if you have those analog ammeters with a needle, those work well also. Thanks for watching. Remember, what one fool can learn, another can.